Hello, friend. Myself Sanjeev Dwivedi, and on behalf of Vidyalankar Institute of Technology, I welcome you all in this Java session. Uh, in this particular series of session that I will be conducting, is the intention is to clear the basic concepts of Java that the graduates are going to appear for interviews. So they should be able to answer questions that may arise during the interviews. So we are basically going to cover the concepts of core Java. Now we'll start with the session. The first thing is about Java is object-oriented programming language. The question arises, what is object-oriented and how it differs from procedure-oriented? You must have studied C++. That was the first object-oriented programming language that you studied. Now it was different from C, and Java is different from C++. Well, when we talk to students regarding object-oriented, procedure-oriented, the first question that arises to many of the students is, how do I decide which programming approach should be employed? It's like if a student is given to write a program to find roots of quadratic equation, it can be written in C, it can be written in C++, it can be written in Java. So, and on all these three are correct. So which one I should employ? This is the big question. Well, we're going to answer this question because object-oriented and procedure-oriented are approach of solving a problem. Like if someone asks me, write a program to display roots of quadratic equation. So the value of A, B, C are not important. The first thing that comes to my mind is procedure. What is the formula to find roots of quadratic equation? But if someone asks me, okay, okay, if I go to bank, let's say if I go to bank and I go and I ask the person, balance batao, what's the balance? I have to specify the account number. So the balance is stored with respect to account number. The result of a student is stored with respect to roll number. My ticket status will be stored with respect to PNR number. My cell phone details are stored with respect to SIM number, IME number. So when it comes to these real world problems, the data is important. Procedure is not important. It's like if someone asks me, if I enter a class and I ask a question, naam batao, naam, give me the name. The student will be puzzled. It's like I've not specified name of which particular student, because name is with all, but I have to specify, okay, give me name of this particular student. I have to specify the person. So when it comes to procedure oriented programming language, the question is how. Procedure is important, process is important. It's like kaise. And but when it comes to object, whose data you're asking for, kiska. So this approach, when we are storing and processing data with respect to someone or something, it is object oriented. But here in procedure oriented, data is not stored and processed with respect to someone or something. The emphasis is not on data but on procedure. Here the emphasis is on data and not on procedure. And so we can say that data is important in today's scenario, especially when I'm talking about solving real world problems. So it is used for solving real world problem, and procedure is basically for computing problems. So where process is more important, procedure is more important, there will employ procedure oriented programming language. So if I go back to my question, like write a program to display roots of quadratic equation, now I can confidently say, even though I can write it in C as well as in Java, C will be more opt because the approach to solve this problem is procedure oriented. So this is how we will decide, depending upon my requirement, I'm supposed to employ object oriented or procedure oriented. The next thing that is very important with respect to Java is platform independence. Now, before we go ahead with platform independence, we must understand what is platform dependence. Okay. Now, suppose I'm having a C program. I'm having an XP machine and I'm writing a .C code. Now, C is a high-level programming language, but for my machine to execute, it must understand it. I cannot write a low-level code or machine code. It is difficult for me to write a low-level code or machine code. So what we do is we write high-level code like C, C++, Java, and so on. Now, let's say what happens with C is I have written a source code. Now, my C compiler will convert now into machine code. Now, when I say machine, I must emphasize it is native machine code, because my machine is XP. So compiler will directly convert it into XP understandable code. So now I'm having two files. It is .c file and .exe file. Now suppose it is e1.c, so this will be, let's say, e1.exe. So the e1.exe that we got here is XP understandable code only, correct? Because it is compiled on XP. So if I take that e1.exe and I try to run on XP, it will execute. But if I copy this e1.exe and try to run it on Linux, it will not execute. Try to run it on Mac, it will not execute. Now the point is, because the output of the compiler is XP code, I cannot take that compiled output. I cannot port it on like Linux or Mac OS. So it is not portable. So it comes with restriction. If you compile a C program on XP, it can be executed only on XP. If you compile it on Linux, only Linux, and so on. So we say it is platform dependent. We say it is platform dependent. So the next question arises is, why do we need independence? So independence, we can visualize, like if I compile a source code on C, I should be able to execute it on Linux. If I can do that, it's platform independence. But why do we need so? Just try to understand about web application. Now, if the app that we are using are not source code, they are compiled code. So it has been created on some other machine, compiled. The compiled code is uploaded, and we are downloading and executing it. Now, even when I'm talking about web application, that those executes on browser, they must have been created somewhere else and on different machine. So basically, when we have intention of creating a web application, it cannot be built with a language which is platform dependent like C. So we should be thought of creating a language that should be platform independent. So that's the need to create a web application. We need something which is platform independent. Now let's see how do we achieve this in Java. Here we have. Okay, in Java, what happened is, whenever we install Java on any machine, on top of that OS, Java creates a virtual machine, an environment of its own, JVM. So if it is XP, I install Java, it creates JVM on XP. If it is Linux, it creates JVM on Linux. If it is Mac OS, it creates uh, JVM on Mac OS. So basically, my compiler cannot see my underlying OS. My compiler can see on every machine is JVM. So even if I compile it on XP, my compiler can see JVM. If I compile it on Linux, my compiler can see JVM. It cannot see the underlying OS. Now that's the beauty of it, because if I am having a Java source code, let's say e1.java file on XP operating system, and if I compile it using Java compiler, Java C, the output is not native machine code because my compiler cannot see it directly. The output is that JVM understandable code known as bytecode. It is .class file. So if this is e1.java, this is e1.class. It is an intermediate code because it is not understandable to the machine. So it will not execute. But the point is, we are stuck here. What we got is an intermediate code. So once the compiler output in C, what used to happen is the output of compiler was executable code. You compile it and run it. Here it's not like that, because my underlying OS cannot be seen by my compiler. There is a JVM. There is a runtime environment which is created. So my compiler can only see this JVM. So the output is this JVM code, which we call it as bytecode. So we need to compile it again. So on every machine where you have installed Java, there is one more compiler, just-in-time compiler. We also call it as interpreter. This just-in-time on XP will convert this bytecode to XP. This just-in-time compiler on Linux convert bytecode to Linux, and this converts bytecode to Mac. So what we have is, since this machine has XP code, this machine has Linux code, and this machine has Mac code, they can execute and give the output. So what's the point is, you compile it on XP, you take that compile code, bytecode, and you run it on any machine that has Java, be it Linux, be it Mac OS, or be it XP. You will get the output, because on that machine where I'm porting it, it will have JIT compiler. So if I'm, which will convert it into native code. So I take this bytecode from XP machine, I paste it on Linux machine. Linux machine will execute it. Now here JIT will come into force. It will convert it into Linux code. And since on Linux machine we have Linux code available, so it will generate the output. So what the point is, you compile a code on one machine and execute it on any other machine. That will make this as platform independence. And hence Java was the first language that actually paved the way for the development of web-based application. So let's see what it says in PPT. So platform now. This is what is platform independence? You create a program on one machine, one OS. You export the output of the compiler on other machine, output of compiler, not source code, mind you. And if compiled code executes on other machine, then it is platform. Now, what is the need for web application to implement? We need platform independent programming language. So that's what's the need of the hour. So it all started for the development of Java. So Java is platform independence because if a Java file is created on a machine, let's say Microsoft, the compiler converted into .class file, machine will not understand bytecode that we have seen. So we have another compiler, JIT compiler, which will convert bytecode into native machine code. So a Java program compiled on one machine can be executed on any other machine. So this is very important aspect when it comes to understanding Java. The first and foremost important feature of Java that made it so successful is Java is platform independent. This is we have seen. So this was about the basic introduction of Java, the basic comparison between object-oriented and procedure-oriented. Remember this: whenever we are storing data with respect to someone or something, it is object-oriented. And if you see across, the data is stored. Like the government of India has my financial transactions stored with respect to my PAN number. Government has all my data stored with respect to Aadhaar number. So these are scenarios where we are storing and processing data with respect to someone or something. So this is about the basic platform independence. In future lecture, we'll talk about the other details in Java. Thank you very much. Remember, you must always refer a reference book in Java to complete reference. I mean, it's very nice book. It is basic, written by Herbert Schill, and I'll keep on mentioning this in my every video. You should refer a complete reference, Java complete reference. Thank you very much.